Hello, welcome back to this segment on mixed data type expressions and typecasting. Up until now, we've kind of avoided this issue and we've done our arithmetic expressions using only one data type. Our data types are double and int. There are going to be more, but if we just think about these two, then we can apply the concepts to all of the data types when we look at the other ones. I haven't told you this yet, but the operators, the arithmetic operators, also have a data type associated with them. Recall we did discuss the difference between these two statements, 10 divided by 3 and 10.0 divided by 3.0. 10 divided by 3 is an int division because there are no decimal points. 10 and 3 are int literals, and the answer is an int. So an int operator evaluates to an int, and a double operator evaluates to a double. And how will we determine what is the data type of the operator? At the division sign, the slash is the same for all of the different data types that we might be using. And we will determine what the data type of the operator is based on the data type of the operands. So in this code snippet here, I have some int variables declared and some double variables. And I'm going to demonstrate here when you have an expression or a statement that uses variables of different data types, what actually happens. So let's look at the first one. Double result gets A. A has 10 in it, and we're going to assign 10 to double result. But double result is a double variable, and it can't have 10. It has to have 10.0, which is a double value. So in this statement, there's a promotion from 10 to 10.0. That doesn't sound very significant, but let's look at the next one. We have result gets D1. Result's data type is int, and D1 is double. Now we have a problem. D1 has 4.5. We can't put 4.5 in result. It can only hold an int. So this statement has a demotion, and some data is lost. The 0.5 is lost during the execution of that statement. So we have this concept of promotion and demotion. When we go from int to double, we have a promotion. And when we go from double to int, we have a demotion. Let's look at this one. Result gets A divided by B. This is an easy case. All of these are ints. So we have an int division. That's the data type of the operator. We look at the A and B and we see those are both ints. So the data type of the division is int. And it evaluates to an int, in this case 3. And 3, an int, is assigned to result, which is also an int. So we don't have any promotion or demotion happening there. The next one is also easy. The division in this case is a double division, the same operator but a different data type, and we know that by looking at the operands D1 and D2, which are both declared to be double. So here's another code snippet, and we'll start to look at interesting things that happen when we have mixed type arithmetic. In this first executable statement, double result gets A divided by D2. What is the data type of the division? Well, we've got an int divided by a double. There is no such thing as an int divided by a double. We have to do the division either in int or double. So C will make a decision for us, and it will always decide to promote. So what happens first is the 10 that's in the variable A gets promoted to 10.0. No information was lost. That's why C decides to do the promotion. 10.0 divided by 3.1, whatever that evaluates to, it's a double. So the division, the data type of the division in that statement is a double. In the next one, we have double result gets A divided by B. Even though we have a double variable in the statement, the division is in int. It looks like the programmer might have wanted 10 divided by 3 to evaluate to a double because they have a place for the answer which could hold the decimal point, a double, but that's not what happens. At the time this statement executes, the first thing that happens is the division. The operands of the division are int, and the division is done in int, resulting in an int. And then, when we assign the int to the double result, it gets promoted and goes from 3 to 3.0. But the information was already lost. The 0.3333 was lost because the division was done in int. So the key here is the data type of the operator is decided at the time the operator will be executed. Here's another example with ints and doubles, and we have a more interesting arithmetic expression a plus b divided by d2. What is the data type of the addition? Well, if we just look at a plus b, we would say the operands of a plus b are of the plus sign are both ints. So the addition must be done in int, but it isn't. In this statement, the division happens first. It has a higher precedence. So we look at the division first. It has b divided by d2. The first thing that happens is that the value in b is promoted to a double. It goes from 3 to 3.0, and now we have a double divided by a double, results in a double. The next thing that happens is we have a plus the double result, a plus the double that we just evaluated. The value in a is promoted to a double, and the addition is done double plus double. When we have mixed data type expressions, we're going to have C always choose to promote from the smaller data type to the larger data type. So there is less room to store information in an int than there is a double, and when C has a choice, it will always promote. In this expression, we have int variable gets double variable. There is no way to promote int variable to a double. The int variable was declared as an int, and we won't be changing its data type. When we have these promotions or demotions, it's only a temporary change for the purpose of evaluating the statement. So in this case, double variable is assigned to int variable and some information is lost. When there is a demotion in your code, C will generate a compiler warning. So if you look at compile time at all of the messages, it will still say that the build succeeded, but if there is data lost due to a demotion, there will be a warning message generated. You can choose to ignore the warning message and your program will still run, but you shouldn't. You should try to write code that compiles without any warnings, and you can do this if you really do want some data to be lost. You can use an operator called a cast operator. People call this typecasting. The last line on this slide is an example of a downcast. So we put the data type inside of parentheses, and what's on the right of it will be evaluated as that data type. So this statement, int variable gets int double variable, is saying I want to take the integer part of the double variable and then use that in the rest of the statement. Double variable, I don't know what it had in it in this case, but the decimal point and what's past it would be thrown away. by the typecast operator. You won't generate an error or a warning message in this case because you as the programmer are saying, I know that I'm changing the data types and that some information will be lost when this statement is being executed. The cast operator is temporary. It doesn't change the declarations of your variables. You can't change the data type of the variables once they're declared. The cast is only for the purpose of executing the statement. So we have here an explicit upcast, and this is fairly rare. You would usually just allow C to do the promotions. You won't get, or the upcasts. You won't get any warning messages in that case. Here's one of the few cases in programming where you have to explicitly do an upcast. So look at this expression, double A divided by B. What happens first? The cast operator is unary. It has only one operand on its right. Unary operators, by and large, have the highest precedence in any language. So we have two operators, double, the cast operator, and the divide, and we would do the double operator first. So the value in A, 10, becomes 10.0. Now we have 10.0 divided by B, which is an int. B will be promoted implicitly without an operator, so that we would have a double divided by a double. So in this case, we wanted to do the division in double, and we only had to upcast the left-hand side and allow the right-hand side to be promoted by the language itself. So in this simple line of code, we have an explicit upcast, or an explicit promotion, and an implicit promotion, where the data is upcast by the language so that we have a double divided by a double. When you have complex arithmetic expressions and there's mixed data types, it can be fairly difficult to go through it and figure out what is the data type of each of the operators. So I've written a fairly complicated expression here. Result gets double B modulus A times B plus D1 times A. I have no idea what that would be computing, but what I would like to do is to go through this and say which order the things happen in. So as we read down through this, what happens inside the parentheses happens first. So B modulus A, 10 mod 3 is 1, and we'll put the 1 there. And then inside the other parentheses, we have a double times an int. The first thing that happens is an implicit upcast of the int to be a double. So now we have D1 times 10.0, and it evaluates to 45.0. The next thing that happens is the cast operator. So the cast operator, double, just changes 1 to 1.0. Multiply by B. What would be the data type of the multiply? We have a double on the left and an int on the right, so the multiply happens in double, and it evaluates to 3.0. Then we're going to add the 3.0 to the 45.0, and the result is 48.0. So the whole thing evaluated to 48.0. And the interesting part of this example is that we can evaluate the operators in order and notice what the data type is of the operator as we come to each one. Here's some practice, and by this time you should be very comfortable going into the development environment and typing some C code that does arithmetic expressions and assignment operators and output statements. So what would be a good idea, I think, is if you evaluate these with a pencil first and then verify your answer with the compiler. So a C program that would output the value that's in result or double result. You should be able to go through these with a pencil and get the right answer pretty much every time, although everybody makes small mistakes when they're doing it by hand. But this is the level where we should be at this point in the course, that you should be able to evaluate these mixed data type arithmetic expressions that include cast operators. Quick review of the concepts then. In this segment, we talked about operators having a data type, and also literals have a data type. So if you write 10 in your program, its data type is int, and if you write 10.0, its data type will be double. And the operator's data type, well, first of all, operators work on operands of the same data type. So if you try to do, for example, an int divided by a double, C will promote the int before the division so that in effect the execution of the statement is a double divided by a double. So the operators will only work on like data type operands and will promote until the operands are of the same type. The data type of the operator is determined at the time the operator executes, and this is independent of whatever data type might be used in other parts of the expression. So if the statement contains some double variables, it doesn't necessarily mean that everything in that expression is going to be done in double. C will promote your data from the smaller type to the larger type in order to avoid losing data. And in general, programmers are allowed to write code that has implicit promotions in it. There will be no warning messages generated, and are not supposed to write code that would have warning messages generated, which would be an implicit demotion. So at execution time or at runtime, if there's an implicit demotion, then some data will be lost, and that should be written explicitly by the programmer if that's the intention. Typecasting, or using the typecast operator, is when the programmer wants to explicitly upcast or downcast the value for the purpose of evaluating the rest of the expression. I think that's all we need for typecasting. We'll try and do some examples in the next segment that will require us to do some typecasting and use mixed data type arithmetic so that we would have the right answers in the problems that we're solving. So we'll do some more, we'll do more programming in the next segment, I promise. I know that these parts have been a little bit dry, the logical operators and the typecasting. We'll get back into programming and making loops and selection statements in the next segment. See you then.